There you go. All right. Let us begin with a word of prayer. I will start. Heavenly Father, we thank you for this day. I thank you for these students. Thank you for the rain. And I just pray you be with us today. Help us to be able to understand the solution to the quiz and just to review any questions that remain for the test Wednesday. Lord, in your name I pray. Amen. Okay, so I got your quizzes, I guess, right? And so I forget who it was I emailed and told you to look at the cross ratio for problem 1, part A. That's absurd. Like, why bother doing that? It's obviously a translation. That's a simple fractional linear transformation. You shouldn't really need to do calculation for that one. You should be able to look at it and go, it's a circle shifted over 1 unit, so I just add 1 to z, right? That's what you were saying? That's what you said? Stick to your guns. Let's see here. All right, come on. Come on, email. It's freshly scanned right before class, so I have to upload it here. All right, so the first one was really, I hope, not too hard once you saw through it. Now, I would imagine that if you wrote down the cross ratio, the calculation was still actually pretty easy if you did it. Yeah. But it's just unnecessary, right? So if you're trying to find a fractional linear transformation that goes from this to that, all you're doing is shifting all your points by 1, so you just z plus 1 is the mapping, right? And that is a very special case of fractional linear. Remember, fractional linear transformations include dilations, inversions, and translations, right? And combinations thereof. Yes, Sharon?
Will this be posted at the end of today?
Of course. I would like to post it right after class, but Michael is throwing a monkey wrench in my plans.
You just don't have to accept his quiz.
Just don't accept Michael's quiz. Okay, Sharon.
I'm just kidding. Hope he's not watching this.
So part B there. There we go. Let me turn off half these lights so it shows up better. So I think part B was actually a good place to use the cross ratio. Oh, other way around. Yeah, thanks. Any questions about this?
So if it's from Z to W, your final answer is W in terms of Z, right?
W equals f of z, yeah.
Okay.
I mean, there's some function that goes, if we're mapping from the z plane to the w plane, and you've got some particular geometric ambition, you want to take a circle to a line or a circle to a circle, whatever, you're looking for f of z of the form az plus b over cz plus d, such that whatever happens, happens. Now, the major theoretical result that we discussed, haven't proved, but you can, is that if you pick 3 points, you can find a fractional linear transformation. We'll take those 3 points and map them to another pair of 3 points, right? So basically, I just need to pick 3 points, and then, so I picked 1/2, 1 plus I over 2, and infinity. Infinity's nice. Infinity's easy, right? And then I just plugged into the cross ratio. I want to map it to 0, 4i minus 4, and 8i. I mean, infinity's got to go to 0. I'm not sure that that's up for grab. I don't know. It just seemed natural to me to map infinity to 0. I thought that would make a nice formula, all right? And so I just set up the cross ratio and then calculated. Yep.
How do you know which points are which one? Like I understand where you get the z points, but how did you get the w points? Did you just choose random ones?
Well, I started with infinity being 0, really. I mean, I don't know.
That's what I had a lot of trouble with. I couldn't figure out which points to choose.
They have to be in the same order, I think. So how did I get them? I chose 3 points in a circle.
But did you start with the order of z, or did you start with the order of w?
I don't know. Which one did I start with? I don't remember, honestly. I think I started with the one in Z just to pick 3 points, and then I said, well, that's the circle. I knew I needed 0 in the mix, and it's just easy to work with the top point and the side point like that. They're easy to find. They're not arithmetically cluttered. I could have picked 3 other points. I mean, you could pick 3 ugly points that are all really close to 0 and probably make it work. It might give you an uglier looking formula. I think there are many, many fractional linear transformations which take that line to that circle, other than the one I have. But I haven't proved that either. That's a speculation. Yeah.
So you don't have to go from, like, because you went from 1/2 to 1 plus I over 2 to infinity, you don't have to go from 0 to 4i minus 4 to 8i. It's the same formula you go, like.
Well, like I said, I mapped infinity to 0. I mapped 1 plus I over 2 to 4i minus 4, and
Okay.
I mapped, I think 1/2 to 8i. They're in the same order, right? I mean, middle has to go to the middle, and the ends have to go to the end. I think you could flip it over.
So does counterclockwise versus
Now,
clockwise matter in terms of order?
that would matter if we were not looking at just the circle. Like, suppose you want to think about not just the boundary curve, but the region. So if I go 1/2 I plus 2 at infinity, in other words, if the line is parametrized in the upward direction, if it's oriented upward, right? If you walk along the line, you can envision that the what side will be? So the left would be that side, right? So that would actually be the half plane. The real part of z is less than 1/2. So the order of the points is maintained, right? So I'm going 8i to 4i minus 4 to 0. So that would actually give you what kind of orientation of the circle will be counterclockwise. So is the inside, where's the inside of the circle? It's actually inside, right? So this would actually map that left half plane to the disk, like the Cayley map we looked at. So if you started worrying about which region maps to which region, it matters the order of the points. But the question wasn't about that. The question was just map a circle to a line. So you have more freedom in what you could have written. Yeah.
Could you just do 8i, 4i, 0?
8i. 4i is not on the circle, though.
So to get those points, you just map the circle and found 3 points on it?
Yeah. That's the result. 3 points fix a circle. It's true. Sharon's like, is that true? I saw her thinking. No thinking, Sharon. I'm just kidding. Please think. I know this may be unsettling to you, but I mean, there's great freedom in what you can do here. My solution's not unique, by no means. But I did check it, right? That's easy enough to do. So I end up with minus 4i over z minus 1 after I cleaned it up. And you can easily see that if you plug in infinity, you get 0, right? And if I plug in 1/2, it maps to 8i. And if I plug in 1 plus I over 2, it maps to minus 4 plus 4i. So you can see what I did was on the level.
Is there any chance we'll get the rest of our missions back or solid moving back before the test or not?
The chances are very good, now that you asked that question. Austin? Oh, yes. Josiah? Sure. Michael? No, here. How about I give you Michael's? You'll see Michael. Malia? Simon? Oh? Oh? What? Hey, what?
No, I always find I'm trying to remember, but it's down I.
Well, this is very neat handwriting. Not, probably not Sharon. That's not yours?
Is it a good grade or a bad grade?
Yeah, that would
It's not
be me.
mine.
That would be me.
Oh, that is you. Okay, okay. Oh, okay, okay. There's yours, of course. Thank you for asking that question. I think I told Daniel like Saturday, hey, I need the homeworks graded. They have a test Wednesday. I need them. And then he graded them pretty quickly, so I'm happy. Although, so Obviously, if you have questions about the grading of these, you probably should ask me after class. But if you have questions about the concepts here, if there's something you're missing, then we can talk about that once we're done with the, solution to the quiz. So I'll try to get on with that. If you don't like the grading,
If we don't like the grading, can we lynch them?
you can you lynch Daniel? I don't know. You are in Lynchburg. That is true. It is our proud tradition, but no. Well, first you got to find somebody taller, right? Because you have to pull up. So if you had like a ladder maybe and the proper pulleys, I don't know.
Oh yeah, let's give Lorenzo ideas.
Oh, I think the 5th floor would be the logical thing, right? Because you got the gazebo to work off. You can easily tie a rope to that, and you just got to push them over the edge, and then you're good to go.
The conference room in the math department.
Conference room in the math department.
That could be
Okay, I'm going to move on. Next problem. You're supposed to find a fractional linear transformation which fixes the points 1 and minus 1. So here I think the cross ratio is probably not the right tool. I just fed it 1 and minus 1 and said, okay, so 1 goes to 1, minus 1 goes to 1, that gives you this and that, which gives you a plus b is equal to c plus d, and it gives you b minus a is equal to c minus d. So you add and subtract these equations, it gets you b equals to c and a is equal to d. Plug those into the general form, and that gives you az plus b over bz plus a. But if you divide this by a, provided a is not equal to 0, it gets you to the form that we wanted. Simple as that. Now the question is, why is a not equal to 0? Well, if a were equal to 0, that would imply that b over a was equal to infinity, which would mean that t of 0 was equal to infinity, which contradicts the given data. So you know a is not equal to 0. Any questions about that one? Okay. Well. Problem 3, I hope you guys got. I kind of worked this in class with sine and cosine, right? So now there is another way to solve this problem, right? Just brute force. You could write the definition of cosh and sinh down and work out the exponential laws, and it would simplify down to 1. That's also a valid solution. But this is the lazier solution, so I wanted to show you this one. Okay. Problem 4. Calculate the set of values of 1 plus I. Now, 1 plus I to the I. If I asked this on the test, I would try to make my grading easier by asking something like, please leave your answer in Cartesian form. Because as it's currently stated, you really could, you arguably could stop at my first equation. And that is the answer. Right? I mean, it's the exponential of I little log of 1 plus I. The point is, little log has many, many values, and those many values give you many different values. In particular, you get these ones. Any questions about that? So generically speaking, the point here is complex. A complex power is understood in terms of the complex logarithm, little logarithm, and that has many values. Yes!
Yeah.
Michael exists!
I missed
Woohoo!
the bus.
You missed the bus.
Yeah.
Hate the bus.
I know, right?
Would it be, I know you said you could stop at the first line, but why did you put it in terms of cosine and sine?
Because I wanted to show you the kind of answer I would want on the test, if I was to ask such a question.
I definitely left it at the line before it.
I mean, even that's not quite
I mean,
Cartesian, right? Cartesian, strictly speaking, should be a plus ib. What's a? A is cosine natural log of the square root of 2 times this stuff. B is sine of the natural log of the square root of 2 times that stuff, right? So, and as k varies, you get different values there, right? You get a whole sequence of things. Remember in the notes, I work out I to the I. Strangely enough, is real valued. All right. Problem 5. Problem 5, you're supposed to show that the quotient, the modulus of the quotient is the quotient of the moduli. I think the way to go here is to square it and use conjugates, right? So z over w squared is z over w times z over w conjugate, but properties of conjugate, which I prove below, say that z over w conjugate is z conjugate over w conjugate. Then you multiply and you get z conjugate, and you get modulus squared over z over modulus squared w. But then as the modulus is non-negative, it implies the needed the desired result. Any questions about that? Now, I said in the problem statement you could use properties of conjugate, right? So I didn't expect you to prove that, the conjugate of z over w is equal to the conjugate of z over the conjugate of w in this problem. But that would be a fair question, right? How would you attack that if I asked you?
So you actually through that not using.
Yeah, let me state it carefully. So how would you, if I asked you, show, z over w conjugate is equal to z conjugate over w conjugate, how would you attack such a problem? X plus iy, that is one way, of course. That's a bad way. No offense, but that's a bad way. That is a way, Zivan. I mean, not. But that will eat a lot of your time. There's a better way. How about this? What did we already know? If you're given, let's suppose that we're given zw is equal to z, right? So on my test, right, if you feel like, well, am I allowed to assume that? That's totally the kind of question you're allowed to ask me. Is it okay for me to assume the product of the conjugate is the product of the conjugates? You could ask me that. Depends on the question. If the question is to prove this identity, then no. But, sometimes professors will be like, well, that's almost the same thing. So that, assuming that is like unfair. I want to remove that kind of ambiguity from your test-taking experience. So you come ask me a question about that, all right? If you have a question like that in your mind, just ask. Anyway, so how about this? So z over w is equal to what? Z times 1 over w, right? So z over w conjugate is equal to z conjugate times 1 over w conjugate. However, w divided by w is equal to w times 1 over w, for w not equal to 0, right? We're assuming w is not equal to 0 in all of this, I should say. So what's that say? This is 1. So 1 conjugate is equal to w conjugate times 1 over w conjugate, which proves what? So therefore, I can take that, right, and return up here to get that this is z conjugate divided by w conjugate, right? Which proves what I wanted to prove. There are other ways. Now, if you didn't see this way, of course, I think this is the best way. But with x plus iy is also a way, yeah. And that's actually what I have in my box over here. Oh, you got it? No, it's okay. I'm already back here. It's no problem. So, this is how to show that 1 over something, the conjugate of 1 over something is, 1 over the conjugate of that in terms of x plus iy notation, right? So, it kind of depends. Whether you want to use the x plus iy or you want to use the other notation, it kind of depends on what you're comfortable with. But anyway, any questions about that? I'm going to go on. But, pay attention to what I say that you're given. If I say you're given properties of conjugate to work with, maybe you should use that. If I say do not use properties of conjugate, then you're not supposed to use that. I'm expecting you to give some different kind of argument, right? Like from x plus iy. Problem 6. This is a backwards differentiation problem. So the point of this problem is that is a difference quotient of tangent. But you know how to differentiate tangent because it's sine over cosine, and of course that's 1 over cosine squared with the quotient rule. And so when does that calculation make sense? That calculation makes sense precisely when cosine is non-zero, right? So the condition that you need on z naught is that z naught is not a half integer multiple of pi. That's it. Now that begs the question, how do I know that cosine of something is 0 only for those values, right? That's something that you should be able to prove on the test also. It's an important question. How do you show that the zeros of cosine are just the ordinary real zeros? Here's how. I'm not expecting this in your proof. And so the thing that I've got the star next to, this actually, you could have written none of this and still got full credit on the problem in the quiz, okay? So I'm just taking this as an opportunity to remind you of this is the kind of argument you should be able to give. How do you show that the only zeros of complex cosine are just the real cosine zeros? Well, cosine of z is cosine of x plus iy, right? But we have the adding angles formula for complex cosine. Who knows? That might be another problem on the test if I was to ask this. Sometimes I'll do that. Like, first I have a problem where you prove that the addition angles formula works for complex cosine, and then maybe the problem after that would be show the real zeros of cosine are just the ordinary zeros of cosine, right, in the real sense. That's the kind of question chain I've asked before. Yep.
How would you show that the addition formula is true? Because you just write cosine of x plus iy equals all of that. What would be the difference if you were proving that?
I would have to go back to base principles, I suppose.
And make it in terms of write cosine as 1/2 e to the x plus iy.
Yeah, so cosine of z would be 1/2 e to the x plus iy plus, thank you, e to the minus x minus iy. Da, 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 da.
And then do the fun things with the algebra.
Mm-hmm. That's one way. Okay, getting back on track here. So you have that, right? If that's equal to 0, that means the real and imaginary parts are separately 0. But hyperbolic cosine, when's at 0? Answer, never. Hyperbolic cosine is greater than or equal to 1. It's at its smallest value at 0. And then it's always above 0. It's always above 1. So if the product of cosine and cosh is 0, that means the cosine has to be 0, right? But if cosine is 0, sine cannot be 0, right? Because sine squared plus cosine squared is 1. So if cosine squared and sine squared were both 0, you'd have 0 equals 1, which would be problematic. You don't believe me? Sine squared theta plus cosine squared theta is equal to 1, right? They can't both be 0. It's immediate from that identity, right? Okay, so if cosine is 0, sine can't be 0. But if sine is not 0, that means that the sinh must be 0. But the hyperbolic sine is only 0 at 0. How do I know that? How do I know hyperbolic sine only has 1 0? Do you guys know?
Because of the writing it in terms of e to the x plus e to the negative x, or in this case, what is it?
I'll use y, yeah, sure. Sinh of y is 1/2 e to the y minus e to the minus y, right?
And so that has to be y equals 0.
Well, if this is f of y, what's f prime of y? It's cosh of y, right? Which you could, more specifically, is e to the y plus e to the minus y, right? This is greater than or equal to 1. Anyway, it's clearly positive. That much you can agree, right? That means sinh is strictly increasing on the whole reals, right? So it can't have 2 zeros. It can't turn around. It's nowhere. It's got no turning point in its graph, right? So if sinh of 0 is 0, that's it. That's it. Game over, right? And of course, sinh of 0 is 0. That's the only 0 of hyperbolic sine. So anyway, with that knowledge in mind, that shows me that y has to be equal to 0 for the 0 of the complex cosine, right? Because I get sinh of y is equal to 0. That means y is equal to 0. So I'm looking for y equal to 0 and x such that cosine of x is equal to 0. In other words, the only zeros of complex cosine are just the real zeros. So, any questions about this? So that was, again, the main point of that was just it was a sneaky backwards differentiation problem, right? I decided not to ask one of those in Math 126 this semester. They have some in their homework, but I stand by my decision. I hope you guys got this one, right? I think it's a little bit boring after you read my examples in the notes, right?
I don't like these.
You don't like these?
No, I like using the Cauchy ring equations.
Michael doesn't like them, they'll probably be on the test.
I mean, it's okay if they're on the test. They're easy. I just don't like them.
You don't? So you don't like them, but you'll tolerate them on the test, as you're saying. Okay.
3 points.
3 points. So you feel like it's too easy.
I guess that's about right.
That's good. That's the feeling I have about the theorem of Carat-Theodori. It's just too easy. That's what makes it so fantastic. It's like something for nothing, almost, isn't it?
Yeah.
Yeah.
Sounds about right.
So the trick that I have managed to work, this works for the polynomial examples at least, you just add 0 basically, and that makes f of a appear, and then everything that's left over has to be z minus a times the difference quotient function, the phi of z, right? That's just, it's going to happen. It's kind of like when you're working the difference quotients in calculus 1, you know that you're going to be able to factor out x minus the value you're calculating, x, whatever. If you're calculating the derivative at 5, you know you can factor x minus 5 out of the numerator. It will happen. It's an inevitability, right? This is that same algebra. Well, I'm glad you guys understand. That's good. This one, there's an easy way to do this problem, and then there's a harder way, right? Easy way is, okay, so we're looking at x plus y plus iy squared, right? Clearly, x plus y and the function y squared are continuous on the plane, right? So we have the sum of continuous functions is once more continuous, therefore f is continuous, right? That's one way we can argue, right? And that would be fine if I don't bind your hands and say things like, please give me an epsilon delta argument to prove that it's continuous, right? And I did not do that actually on the quiz, right? So I won't take off points if this is your argument.
So just because it's falling on the test.
Mm-hmm. Yeah, I mean, there's a basic lexicon of functions that we know are continuous, right? Polynomials, exponential sine, cosine, cosh, sinh, the inverse functions on their appropriate domains. I mean, the list goes on. Formulas whose functions make sense at points in question, which is just a fuzzy way of saying everything you've ever seen that's not pathological. Division by 0, always a problem, right? Square roots give us pause, but less so now. Anyway, this was easy, right? Once you got past, what does he want for the continuity, right? You can see that Cauchy-Riemann is not satisfied because you don't have ux is equal to, you don't have vx is equal to minus uy, right? And that's without regard to the point in question. So it fails on the whole complex plane. Nowhere is this complex differentiable. That's it. Now, you could have attacked this from the difference quotient and probably come to, you could approach it, you could have done difference quotient. I bet if you'd done horizontal versus vertical path at an arbitrary point, you could have found that the two-path test was inconsistent. You know, you could have showed directly the difference quotient fails. That's another argument you could give, but man, it's so much more complicated than this, right? Cauchy-Riemann equations are for sure the no-go tool, in my opinion. Can you guys tell me the difference between holomorphic at z0 and complex differentiable at z0? What's the difference?
For homomorphic at a point, you have to have it be complex differentiable in an open disk around the point.
Exactly. Yes. Holomorphic means that it is complex differentiable near the point as well as at the point. whereas complex differentiable at the point just means that, right? So what's the relation, so I'm trying to find it's my age-old battle with scrolling. Let's see here. Can you give an example of a function which is, say, complex differentiable at z0, but not holomorphic at that point? Something to think about. All right, problem 8. Here is the harder way to look at continuity. So suppose you wanted to show continuous from the epsilon delta definition, right? Then what that would mean is I need to get control of f of z versus f of a plus ib. What to make it less than epsilon, given that, the modulus of z minus a plus ib, parentheses, is less than delta, right? So then I have to go back and play the usual epsilon delta games. And I think I've basically found it. So obviously if you look at this difference quotient, you've got, not difference quotient, it's literally just the difference, the modulus of the difference. We're just thinking about continuity here. By triangle inequality, it's less than this plus that plus this thing, right? Now, I get control of these direct. I can make these less than delta because they're either the real or the imaginary part of the difference between z and a plus ib, right? So the real part and the imaginary part are smaller than the whole thing, right? So I get control over this, this, and this. This is kind of pesky. I need to use some kind of trick to get my paws on that. And so I do the usual thing, which is to make delta be less than or equal to 1. And here's the argument. So if I let delta be the minimum of 1 epsilon over 3, and did I not? I think I forgot to. This is right here. I think I was supposed to put. Oh no. Sorry, I changed my mind somewhere in here. Let's see if it's right. I think it's fine. So suppose that delta is the minimum of 1 epsilon over 3 and 1 over 2 times the absolute value of the y component of the point in question plus 1. So we get to suppose 0 is less than that less than delta. So in particular, this implies that x minus a and y minus b are less than delta, right? Where delta is less than all three of these things. The interesting thing, of course, is that if this is less than delta, which is less than 1, that means that minus 1 is less than y minus b is less than 1. So I can add 2b to this. So I get 2b minus 1 is less than y plus b is less than 1 plus 2b. And if you look at the stuff above, it's easier to see that this does, in fact, imply that the absolute value of y plus b is less than 2 times absolute value of b plus 1. So that gives me control over the size of y plus b by making sure delta is not too big, basically. And then I go and look at the difference, triangle inequality, epsilon over 3, epsilon over 3, epsilon over 3, and then this is less than that, so that cancels and gives us epsilon, hence showing it's continuous. Now, of course, I don't have to ask that complicated a question about epsilon delta proofs, right? But you should be able to do a simple one, right? This one's a bit much for the test because it is a Monday, Wednesday, Friday class, as you guys were just mentioning.
Was complex analysis Tuesday, Thursday last time we talked? Just out of curiosity. I'm just wondering if the old tests are for 1:15 time slot or.
I don't know, but you guys are smarter than them anyway, so I can safely give you a Tuesday, Thursday class. Okay, moving on. To show this is open, there's not the picture on the previous page is very. What happened to my picture? What? Where'd my picture go? I had a picture. Oh man. Well, anyway, I will let you read this. I expect many of you lost points on this problem. you have to be, I mean, you have to be careful. It's a picky question. So it's going to require a picky answer. Now, there's two different ways I can ask about this kind of question, right? So I've asked this question in previous years, basically. Here's like a half. Let me put this away and just talk on the board for now. Thanks. Thanks. Here's a simpler version, something like S equal to Z in the complexes such that the imaginary part of Z is greater than 2. Show it's open. Now, there's a lot of times I'll ask the question as in like an A-B format because I think it's useful to me to see how students are doing. And like A might be give geometric argument or geometric proof. And then part B is to give analytic proof. Right? So the geometric proof is very simple. You pick any point up here, right? Suppose that this was y equals to 2, okay? So you just pick any point, right? And you can just, what do? Choose epsilon equal to, or delta, I guess, in my current language. Delta equal to what? Let me say z naught is x naught plus I y naught. What should I choose delta? Why am I choosing a delta anyway? I'm trying to show it's open, right? Sorry, I said it, but I didn't write it. Show it's an open set. How do you show something's an open set? What does that mean? Every point's an interior point. What does it mean for it to be an interior point? Yeah, there exists an open disk around it, and where does the open disk have to fit, though?
It has to be within the set.
Within the set, right. So I have to pick a delta so that open disk is inside the set S. So what's delta?
2.
2? There's no epsilon here. It has to be in terms of the point. Z naught is equal to x naught plus I y naught.
Why not minus 2?
Y naught minus 2 will not do it, no.
It won't.
Well, if y naught is equal to 1, then your delta is negative, which is problematic. Your heart is in the right place,
Wait,
but your mouth was on the wrong
How
operation.
would y not be 1? Isn't y strictly greater than 2?
Okay, let y not equal 2.2 then. Wait, say y minus 2?
Because that's the distance to the boundary.
Oh, see, okay. Yeah. No, I take it back. You're right. That'll work. I was thinking more lazily. I was going to say something like, I agree. I see what you're saying, Nathan. That's fine. Why not minus 2 over 2 was going to be my suggestion, just because you're making me nervous. You're getting right to the edge. I mean, this is...
See, like, when I did the similar proof that was on homework, like, I tried dividing by 2 to get it, like, further away from the edge. But then I realized, like, I couldn't actually figure out any reason that would help the epsilon argument. So, like, I just made it right to the edge.
Interesting.
Because, like, that was for when it was the upper half plane. Like, the
Right.
same things like y equals 0, essentially.
Well, of course, anyway, but the larger point here, of course, is the answer is not unique, obviously, right? But the geometric proof is basically just, well, obviously you can draw an open disk around any point, right? Because you can choose a delta which is less than the distance to the edge, and then that whole thing will be there. That's the geometric proof, which Michael doesn't like, because he doesn't like pictures. Yeah.
Okay. I don't understand. Why can you put the Z naught right next to y equals 2? What?
Even if it's right close, think of it like a camera. Even if it's right close, you can still choose an epsilon that's infinitely small around it.
Oh, I'm sorry. I didn't tell you this was x naught plus I times 2.0. Okay, that's enough. One.
Because the circle should be infinitely small. And see, this is why pictures are frustrating.
Yeah. That's why you don't like the geometric proof, is it's misleading. Yeah.
You can't draw an infinitely small circle. But
I can. I just did. It's essentially right there. I mean,
that's a really big circle.
you're just looking at it the wrong way. The analytic proof, though, actually means that you say, okay, so let blah, 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 right? I mean, you actually have to furnish the inequalities, so you'd be like, okay, so
Which is also really hard.
z naught equals x naught plus I y naught, right? An element of S, and then propose that delta equals to, let's see, if we're going to be, accept Nathan's proposal, y naught minus 2 is the delta, which of course I don't need absolute value bars. I can just write y naught minus 2 because y naught is, of course, by construction greater than 2, right? And then I then have to show what? That the disk of radius delta centered at z naught is a subset of S, right? Now how do you show that? You pick z equals to x plus iy in the disk, right? And then you show, through explicit inequality work, that z is an element of S, right? This is not the proof. This is a sketch of the proof. The proof, the points, are mostly in you furnishing the details there for part B of this question. This on the board is part B of problem number 10. And my picture somehow is gone. Sorry. The picture for that is something like this, right? If you have 1, right? And if you have 2, and then if this is the middle line, 3/2, there are two cases, right? Either you're here or you're here. So you can either, if we use Nathan's kind of solution, we can use this or we can use that, basically. So you should just pick delta equal to the minimum. This is not my solution there. I used the half idea and suffered through it. But if we use Nathan's idea here, it would be like the minimum of the, let's see here, I suppose that's z naught again, x naught plus I y naught, right? So I want the minimum of, say, the absolute value of 2 minus x naught, comma, 1 minus x naught. I mean, put them in whatever order you want. I don't know. Fine. Let me put it more geometrically. X naught minus 1. That to me is more. It's more clear the intent of this solution, because x naught minus 1 is this distance, right? And 2 minus x naught is this distance here. So you pick the smaller of those two, and it would work. And you probably could give a proof which doesn't even break into cases if you do this. You'll get a lower bound from one and an upper bound from the other. I don't know. I broke into cases, just easier for me to think, but.
Did you specify to give a geometric and an analytic proof? Is it just assumed that you should do an analytic proof? Or some combination thereof?
You give the best answer you can that shows you understand the subject matter. So, yeah.
I mean, I don't know, like, how I would argue that geometric proof you did there is actually a proof. Proof by drawing a circle around the point QED.
That's a proof. You want to see the proof that a cube is homeomorphic to a sphere? This is the proof I saw in my graduate topology course. There's a cube. Here's a sphere. Take a point at the origin, draw this. This line connects to that. This connects to that. It's clearly injective and continuous, so they're homeomorphic. Because it's invertible as well.
I'm going to struggle in grad school. That's too much for me right there.
Don't worry, not everyone's a topologist. And some of them are pickier. Yeah. Oh no.
Delta equals min of 2 minus x, or x, is that x naught? X naught minus 1. What is going on there? I don't get it. What's x? X naught can be anything because it's not bounded.
Well,
no, it's the real part, so it has to be.
You have to, I mean, to show it's open, you have to pick an arbitrary point in the set. So that does say endow x naught with certain rights and privileges. Well, actually, no, not this this example, not really. This one, yes, because it's all about the x. This one is all about the y. You get no condition on x whatsoever. Over here, we just get the condition that y naught is greater than 2. That's pretty much it. It's pretty much all we need, too, to make this delta be logical. You do need delta positive, right? Otherwise, it's not a very good distance.
Yeah.
Yeah, pesky distance.
Delta equal 5 plus 2i.
Then delta equal 5 plus 2i. That somehow seems very appropriate, and yet still very wrong. Let's see here.
Where delta equals 7.
Oh man, grading definitions is such a drag. But it is a good thing. Hey, could you guys show that the complex numbers are connected? How would you show that the complex numbers are connected?
What is connected?
I've asked this on test before. Could you do it?
Yes.
What does connected mean? Yes. Connected means path connected for us.
What?
We define connected to be path connected, actually. Let me be more specific in my question. Could you show the complex numbers are path connected? What does it mean for a set to be path connected? Yeah. Oh, right. Yeah. So can you connect those with path?
Yes.
Can you give me the formula for it? I'll start you out.
Oh, okay. Wait. C1 minus C0
Uh-huh.
such that
There you go.
is an element of
That is
zero.
right in 0 less than t equal 1. So is this in the complex numbers for every time between 0 and 1?
Probably.
Yep. It's a sum of complex numbers.
Okay.
Does it start at z naught? Is it start at z naught? Yep. Does it go to z1? Are z naught and z1 arbitrary? Absolutely. There you go. We have proved that the complex numbers are path connected as the sum total of it. That actually
You
was.
will not get this in your other complex class. Did that make you sad?
I tell you, this question showing something's an open set, it crushes the class. There's usually only like 2 people who can do that. And I'm not talking about the complicated one I gave you guys in the quiz. I'm talking about that one, the half open one. Kind of tired of it though, but maybe I'll still put it there. I don't know. Just try to understand.
Wait, so is it a theorem that the complement of an open set is always a closed set?
Is the complement of an open set always a closed set? I think essentially by definition, because the complement of the complement is back again, right?
Oh, wait. But the complex numbers are open. But the complement of the complexes is the empty set.
Well, the whole complex numbers is both open and closed.
Oh, okay.
There are sets which are both open and closed. It's not mutually exclusive. However, in a connected set, the only sets which are both open and closed are the whole set, or nothing.
See, I'm thinking, would an easy way to prove that what we were just going over is an open set be to look at the complement and show that that's a closed set because you can choose a point on the boundary and all disks on that centered at that point will be
But how
points in the set and on the set.
but how does that show it's closed?
Is that not the definition of closed?
No, you're just talking about the definition of boundary point, which is fine. I mean, but
So won't closed sets have
I've only defined closed in here as the complement of if its complement is open. You could define closed in terms of sequential convergence, but I haven't done that. I don't think. Anyway, you can look at the test from last year. You can ask me questions. Any questions remain? I mean,
Can you ask me what questions are on the test and the solutions to them?
You can ask me that, like, after the test, sure. No, basically what I will do is very simple. I will go back, I will look at the homework that I've assigned you guys. I will look at the homework I gave last year. I will look at the notes. I will look at the test I gave last year. Think about my life. Think about how much grading I want to do.